Hello, it's Mr. Cerisa, and today we'll go over the intro to an ellipse, and this is probably the best ellipse I could draw, but you'll see from pictures in the book some better viewings. So first of all, what is an ellipse? An ellipse is a set of all points that have the constant sum of those points from the foci. So I'm just going to put in some foci here, and you can see if I took it from one focus to a point and then landed back at the other focus, so that would be hitting like x, y, that would have a constant sum of distances from some other one that we choose. It could be down here, doesn't matter, it could be all the way over to the vertex and then back. So all of those will be constant. Okay, so these are the foci, and that's just the plural of focus. So a parabola has one focus, an ellipse has two foci. Another part of this is going to be the vertices, and so the vertices land on the major axis. So let's go over that first. The major axis will be the axis that has the ellipse at the widest part. And so that's the major axis. The other axis is the minor axis. So that would be, in this case, the y-axis. And that's the minor axis. Okay? The foci will always be along the major axis, just like the vertices will always be at the major axis. So vertex here, that's where the ellipse hits the major axis. And so one vertex, two vertices. And those are the ones in blue. The center, of course, will be right in the middle. So in this case, we did the center at 0, 0, at the origin. But that's not always the case. So we usually have HK being for the center of the ellipse. And then finally, also worth noting, in this example are the y-intercepts, but of course if you shifted it to a different center, or you had the y-axis as the major axis, it would be x-intercepts. But in terms of graphing this from an equation, it's easier to think of it as y-intercepts. Okay, you can't see the yellow, so let me put that in green. And so that would be the y-intercept, which you're all familiar with. And then if you were to write the equation of this, so this would be an example of an equation that's centered at the origin. Okay, and then the vertices are really a distance from the center, and then the foci is c distance from the center. And you're like, well, there's no c in that formula. Well, c squared equals a squared minus b squared. So you could calculate out what c is. And then the y-intercepts are the b. Okay, so essentially this distance from center is b, and this distance from the center is a, all the way over, that's a, and then this distance from the center is c, the foci. Okay, and they all come together and they form this equation to calculate whichever one you're missing. Alright, and then another key that I didn't mention is make sure that this equation always equals 1. So if it equals anything else besides 1, divide through by that number, and then you'll have the correct form of the equation. Okay, I'll have more details in following episodes. Thank you, and I hope that this helped.